Hello and welcome to Maths with Jacob. This lesson will focus on permutations and combinations. A special puzzle to warm up the brain cells is on the next slide. The answer will be given at the end. Enjoy. What is the meaning of the following? Good luck with it and see how you go. If we are given a set of objects, we can select a smaller set of objects from the larger set. This can either involve permutations or combinations. Permutations. If we want to find out how many different ways three students can line up, we are looking at permutations because order is important. Let the students' names be Sam, Tom and Ned. The possible number of ways is as follows. So here I've outlined 6 ways that these students can line up. So they are 6 different ways, and order is important. Combinations. We go to the library and we want to borrow 4 books, A, B, C and D. However, the library will only allow us to borrow 3 books. Here we are looking at combinations because order is not important. The possible combinations are those 4 there, because we only have 3 books. We can borrow any 3. We don't care about order. Permutations and combinations using multiplication. Suppose we want to travel from P to R by going through Q first. There are 3 roads from P to Q and 2 roads from Q to R. So here are 3 roads and here are 2 roads. Clearly, there are 3 times 2 equals 6 ways of travelling from P to R. This is the method we use when dealing with very large numbers. So 3 by 2 equals 6. 3 by 2 equals 6. Permutations. In a horse race, a trifecta involves picking the first 3 horses in the correct order. How many trifectas are there in a race with 6 horses? Answer. First place can be any one of 6 horses. When the first place has been decided, second place can be any one of the remaining 5. When first and second have been decided, third place can be any one of the remaining 4 horses. Since order is important, the number of possible trifectas are 6 by 5 by 4 equals 120. Factorial. The symbol n factorial, that stands for factorial, means n by n minus 1 by n minus 2 by n minus 3 by 3 by 2 by 1, where n is the number of consecutive integers from 1 to n. The information just mentioned gives rise to a very important formula for dealing with the number of permutations of n objects which are taken r at a time. NPR equals n factorial over n minus r factorial. If there are 8 cars in a race, how many possible trifectas are there? Here we have n is 8 and r is 3. So NPR is 8p3, which is 8 factorial over 8 minus 3 factorial. 8 factorial over 5 factorial is 336 possible trifectas. Combinations. Remember, when using combinations, order is not important. Some examples where order of selection plays no part are as follows. Choosing 3 class captains from a class of 10 students. You don't care what order you choose the 3 captains, you just want 3 of them. Choosing 4 books to borrow from a box of 10 books. You don't care about the order, you just want 4 books. The number of combinations of n objects which are taken r at a time is NCR, is n factorial over n minus r factorial by r factorial. Here's an example. How many different combinations of 3 captains can be chosen from a group of 10 students? 10C3 is 10 factorial over 10 minus 3 factorial by 3 factorial. That's 10 factorial over 7 factorial by 3 factorial. That's 10 by 9 by 8, etc. So those little dots are multiplication signs. The 7 factorial is that. The 3 factorial is that. So what we do, we cancel that out with that. So we're left with 10 by 9 by 8 over 3 by 2 by 1, and that's 120 different combinations. Here's a quick quiz to help you. Please check through the video at any time. The answer to the puzzle, what is the meaning of the following? The aftermath. A little bit tricky, isn't it? Here are the answers to the quick quiz, and the video is at your disposal.